Here we are at our example 1 from our exterior angle measure set of notes. Now, before we really dive into these examples, what we're going to go ahead and do is just look at the definition to kind of help us with that. We notice that we have this interior angle, x, and this interior angle, y, in that triangle, but we don't have this one right here. However, we do see that we have an exterior angle, z, and pretty much what this definition says is if we were to take that x and that y angle, combine them together, we should get that z angle. And notice how that z angle is not actually connected to the x or y. It's kind of like they're opposite. Those x and y are kind of opposite inside that triangle. And that actually is a definition due to the supplementary theorem, but your high school geometry teacher will talk more about that later on. All you really need to know is, hey, if we take our interior angles x and y, then that's going to be exactly the same as that exterior angle z. All right, so let's see this in action then. So when we look at example A, 1A, we're trying to figure out what is that exterior angle. Well, we can accomplish that by simply adding 36 plus 72, those interior angles. And according to our definition, that should come out to be equal to whatever that exterior angle is. And when we combine 36 and 72, we end up with 108 degrees. So that would be our measure of angle x. Let's go ahead now and look at B. We notice that we have this exterior angle that we're trying to find. And we have those interior angles, 38. And this guy represents 90 degrees. So using our definition again, we can have the measure of angle x is equal to 38 plus 90, which for a grand total gives us 128. Our next one gets a little trickier because this time we're not looking for necessarily an exterior angle. We're actually given that right here, but rather we're looking for that interior angle. Now, according to our exterior angle theorem, though, you can actually still apply the same kind of equation. So we know that we have 120 degrees should be equal to those interior angles when they're combined together. So we have our question mark that we don't know, plus that 50-degree angle. And our goal is to solve for that question mark angle. We don't know what it is, and we can accomplish that by subtracting 50 degrees from both sides. And so, as a result, we can find that that angle comes out to be 70 degrees. So we're still using our exterior angle measure theorem. Looking at D, again, it's that same idea. We don't necessarily know those interior or exterior angles, but we can use our definition to help us out in that process. We know that if we take 80 degrees and combine it with this A minus 5 degrees, we should get the grand total of the outside, exterior angle 2A. Now, we don't know what these items are. We're just setting up our equation based on our definition. On the left side, we can combine our like terms. Looks like nothing can be combined with the A, so we just have A. But then we have 80 plus negative 5. That gives us a positive 75 degrees. Equals 2A. And now we just have a normal equation that we can go ahead and solve for. So we'll subtract A from both sides, get A on, all on one side. So we have 75 degrees equals 2A minus, really that's a 1A, gives us a 1A. And there we've solved for A. A should be 75 degrees. Now, natural follow-up questions tell us to find those angle measures. Well, if I plug in A into, we'll just say this interior angle, then I would have 75 minus 5 degrees, in which case we should get 70 degrees. So that interior angle is 70 degrees. For that exterior angle, that 2A, well, we're simply going to plug in our A in there. So we have 2 times 75, because that's what we found it to be earlier, in which case we get 150 degrees. Now, a nice way to check is just to see 80 degrees plus 70 degrees, we get 150. Notice how that does match our exterior angle, 150. Last but not least, 1e. Again, we're just using our same definition as we had before. This time it's just got a lot of different variables, but we're still using the same definition as we were before. So we have our 2n plus 20 plus our n, those two interior angles. And we're going to set that equal to that exterior angle. And now it's just a simple equation that we have to solve for. On the left side, we notice that we can combine some like terms. So we have 2n plus another n gives us 3n's plus 20. Nothing can be combined with that 20. Equals, on the right side, nothing can be combined. Now let's get all the n's onto one side. So we can accomplish that by subtracting 3n from both sides. On the left side, they cancel out, leaving us with 20 equals 1n minus 20. And then we'll go ahead and add 20 over to both sides, helping to isolate our variable. So we get 1n equals 40. And then that common last step would be to divide this coefficient, 1. Just in case if it is another number, you know how to do it. So n comes out to still be 40. So now that we have found what n is, we have to actually identify all of our angle measures. So for this one, that's just n, right here. That one's nice and easy. We know that that is 40 degrees. This one, right here, we actually have to go ahead and find by evaluating and plugging it in. So we have 2 times 40 plus 20. According to GEMDAS, we're going to do our 2 times 40. That comes out to be 80 plus 20, which is 100 degrees. Now we know based upon our exterior angle theorem that those combined should give us that value, but let's go ahead and plug it in and evaluate just in case. So we have 4 times 40 minus 20. Well, that would give us 160 minus 20 for the grand total of 140 degrees. Now let's clean that up. 140 for this guy right here. And lo and behold, if we take our two interior angles, combine them together, we do get our exterior angle there. Again, though, that is our exterior angle theorem along with those two interior angles.